The Astronomical Society of Victoria with the regular Friday night broadcast on this Friday the 13th, coming to you from the studios of VK3CSJ in Narre Warren South, broadcasting on the prime frequency of on the prime frequency of 3541 kilohertz in the 80 meter amateur radio band, and also streaming on YouTube now, and also on the Discord channel. If you go to the station's qrz.com page, I've now provided information on connecting to the Discord channel. You first have to register on Discord, of course, but there is a link provided that will take you straight to the chat room and also the HD video channel associated with it to make things easy. Good evening, everyone. I hope everybody is fine. For those that are listening in right now, we have a problem with Melbourne television repeater yet again. VK3RTV is producing a black screen. So for some reason there's no video. So one thing or another. So we have to rely on Discord and on my YouTube channel, VK3CSJ. Just type in VK3CSJ in the YouTube search engine and look for the live indication, and you should be able to find the YouTube stream. All right, the 80 meter dipole is still down. I haven't raised the tower. I was going to try and do that today actually, but I just didn't get around to it. So the dipole is not fully immersed into the atmosphere, but we're still getting out a good signal. VSWR is okay, and it's only 100 watts, so I don't think I'm going to cause too many issues with the stream. Anyway, a very pleasant good evening to all. I hope your footy team is winning, which one will win tonight. They're pretty close. So, yeah, anyway, that's another story. All right, we've got a few interesting things tonight, and I've got a couple of videos. Tamitha Scove has her space weather report available. I think it's just a day old, so it'll be pretty current. So I'll run that a little later, and then I'll actually, once I've finished the usual blurb with the ASV, I might run into another video that I've discovered just recently on YouTube. It was done a couple of years ago, but it's presented by Dr. Russell Cockman, who is a former president of the ASV, and he's talking about the Astronomical Observatory, Melbourne Observatory. Very interesting little video. It only goes for about 7 minutes, but I think you'll find it of some interest for those watching the YouTube stream and the Discord channel. There's also an email address, vk3ekh@gmail.com, vk3ekh@gmail.com. If you can let me know if all visions and sound levels are okay. I think they are. It's just a pity that RTV is not picking up any video. If I had the SRT feature where I could just SRT into the system, that might help a little bit. I think if that might work, but I'm not really sure. But that's another story. Okay, so let's see if we go to this. For those that are tuning in for the first time, the ASV is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members, over 1,600 now, I believe. Its activities are coordinated by the Council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our two metropolitan locations One is the Morley Community Village and the Melbourne Observatory. And we host monthly Astro Talks at the Herbarium near the Melbourne Observatory. There was a very interesting talk this Wednesday, actually, last Wednesday. The Society's library is located at the Melbourne Observatory and is open during our Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. The ASV is currently involved in a number of major projects, and we are involved in the restoration, or ASV is at least, is involved with the restoration of the Great Melbourne Telescope, and are also currently working on the installation of a series of remote telescopes at the Dark Sky site, which are pretty much up and running now. And also, once complete, members will be able to have access to it. Thanks to the generous donation from one of its most long-standing respected members, the Leon Mao Dark Sky site, located north of Melbourne in the Heathcote region, has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and wheelchair accessible 16-inch telescope at the Leon Mao Dark Sky site, and makes use of the existing telescopes at the Melbourne Observatory during some section meetings and our members' nights held once a month at the observatory. There's also an 8.5 fully steerable radio telescope with where members can get involved with the radio astronomy section, and that's now almost up and running. There's a few mechanical things still to be worked out, but it's very, very close to getting back up and running. So that's the radio astronomy section, of which I was involved with for many, many years. The ASV logo, which is the Southern Cross and the pointer stars, has a Latin motto, which I can't pronounce, but it basically translates to "This way to the stars." The ASV is governed by a set of rules which should be read before applying for membership. This document can be downloaded from the website, and any person or organisations with an interest in astronomy may apply for a membership of the Society. So there it is. So this broadcast has been going since 1988. The first 20 years was conducted by Russell Ward, VK3DRW. Good evening, Russell and Elizabeth, if you're in earshot. And I took over the microphone some years ago, I think it's about 12 years now I've been doing this. So I might be able to push it to 20 years. I've lost count, actually. I'm not really sure when I took over doing this, but anyway, there it is. Okay, and it looks like the repeater is not behaving, so they're one of those things. All right. What I'll do is, before I go into the first little article here, I've only got a handful of articles tonight because I don't want to go for the full hour tonight, although I say that every Friday, and we always go over 11 o'clock. But I've I've recently discovered, as in this week, that I've got high blood pressure. I've had the whole week off work, and I'm now on high blood pressure tablets as of today. So, it's just one of those things as you grow old. Anyway, I thought I'd mention that. All right, let's go into this video. So if you're watching my YouTube stream, VK3CSJ on YouTube, you'll see it. If you've got Discord, you'll see it there as well. I'm just going to quickly check my Discord and see. Oh, look at that. We've got a heap of people already tuned in. Richard, VK3VRS, Steve, VK3SBX, Brett, g'day Brett, VK2CBD, and Mike, VK3XL. So there'll be at least some people watching this video. But you'll hear it. For those on 80 metres that don't have access to a monitor near their shack, at least you'll be able to hear the sound, and you can imagine the pictures in your mind. So let me queue up this little bit of 7-minute video. It's really quite good, high quality video, very nicely edited. And like I said, it's presented by Dr. Russell Cockman, who used to be a former president of the ASV and still very much involved with the ASV in many ways. And I'm just trying to find this video. It's right in front of me here. Where did I put it? I did bring it across, surely. Where's Tamitha's video? There's Tamitha. Oh, there it is, right next to Tamitha. Okay. All right. All right, let me cue it up. And I think I'll just go right across with it. And I think the audio should be right there for Discord. And we should just go ahead and play it. So stand by.
Hi, I'm Russell, Observatory Guide at Melbourne Observatory, Royal Botanic Gardens, Victoria, Melbourne Gardens. And what I love most about being an observatory guide is showing members of the public planets and the moon and stars. These have great wow factors. There are coloured stars, they can see craters on the moon, they can see the rings of Saturn, they can see the belts on Jupiter and 4 of Jupiter's moons. So they can actually relive the experience of Galileo back in 1610, over 400 years ago. So although this building was built in 1873, Melbourne Observatory itself was established in 1863. It was a successor to 2 earlier observatories, one at Williamstown and one in the Flagstaff Gardens, because there was an essential need to determine local time. In those times, navigation of ships and positions of ships were determined by time elapsed from port, and knowing their speed in knots from the port, they could roughly determine their longitude. And an error of 2 minutes in their timekeeping could be the difference between a safe journey and a journey ending up on rocks. Well, this site was chosen in the 1860s because it was close to the growing city of Melbourne, but it was also on a relative high point. The building that we're in now is a dome building, and people appreciate doing their observing inside a dome building because it could be quite cold or windy outside, but inside this beautifully isolated building, they don't feel the wind and they don't feel the cold air, so it's very, very comfortable indeed. So this is a heavy telescope and with a heavy mount, and it needs to be well supported. So this entire telescope is sitting on a stone pillar which is connected to the ground. The main purpose of that being that it means that the building can be isolated from the telescope so that people walking around do not cause vibrations. So this is by far the safest way to view the sun, because you're not actually looking directly at the sun, you're looking at the sun projected from the telescope eyepiece onto a piece of card, and this disc that we see here is actually the photosphere of the sun, perfectly safely. So sunlight comes in through the lenses of the telescope, comes to a focus at about a point here, and then the eyepiece magnifies that focused image to reveal the sun that we can see with our eyes. Now, we never ever look at the sun directly through a telescope because you run the risk of seriously damaging your eyesight permanently. We're now in the Astrograph House. The Astrograph House was built in 1889. as a special purpose observatory to fulfill the requirements of a project called the Astrograph project, or the Carte du Ciel project. It was a worldwide effort by observatories including Melbourne Observatory, Sydney Observatory and Perth Observatory in Australia, to do a very ambitious project, that is to photograph the entire sky. But imagine a project in the 1890s to photograph the sky, and that wasn't everything, because those photographs had to then be analysed by people so that the positions of those stars could be determined. A location on planet Earth is defined by latitude and longitude. The same applies to objects in the sky. They have two numbers which we term declination, which is the equivalent of latitude, and right ascension, which is the equivalent of longitude. But those numbers had to be determined, and that was done by human computers. And women were employed to do this function. Now, these women were employed by the Victorian government in the public service, and they were the first women in Australia to be employed by the public service. Those photographs taken in the 1890s and 1900s serve as a snapshot in time. Installed in here was a very special telescope called an astrograph, which is a telescope designed to take photographs. So this telescope is not the astrograph. It was removed from Melbourne Observatory in 1945 when the observatory officially closed. But this telescope was installed in its place. Now, believe it or not, this telescope was built by a single person, a Mr. Jeffrey in Bendigo, and it is based on the design that Isaac Newton invented over 300 years ago. It works by using mirrors. Down here in this telescope is a 12-inch mirror with an aluminium reflective surface. The light comes down the tube, bounces off the curve on the mirror. As it does so, it comes to a focus somewhere up here at the end of the telescope. But of course, the light hits a flat mirror, and the light is directed outwards through the tube, and an observer with an eyepiece will be looking at the object at that point up here. In the 1930s, to have a 12-inch telescope, well, that was as good as it got for an amateur observer. There's a building on site called Magnet House, which was designed to measure the Earth's magnetic field, and as a building, it was built without any steel or ferrous metals in it. In fact, the nails that we used were made of copper, because copper is non-magnetic. And it worked perfectly well for many years until the St Kilda Road trams were electrified. And because as electricity passes through wires, it creates magnetic fields, which were enough to reduce the sensitivity of the magnetometers.
And courtesy of Melbourne Observatory, Russell Cockburn, thank you very much for that interesting bit of video. And it was really quite well done. I love that sort of stuff. It's when it gets edited together and yeah, very good. So if I can find any more of that sort of stuff, I'd love to be able to present it. All right, you're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, and we welcome any members from the Geelong Astronomical Society, which has now become a section of the ASV. The Geelong Astronomical Society has just recently merged with the ASV, as the Bendigo Society did. So the Astronomical Society is becoming even bigger as a result of that. So that's good news. All right. Now, thanks, Steve, for your emails, giving me those reports. I'm glad to see that signals and visions are all working very good, except for the repeater. Anyway, all right. Now, the first little article that I've got tonight, courtesy of Astronomical.com, is dealing with the story that I've spoken about in previous broadcasts, dealing with the number of space junk that's in orbit around Earth. And this one's titled Small Untrackable Pieces of Space Junk, which are cluttering our low Earth orbit. And there is a graphic associated with this image, this article. It's just a picture. So there it is. And I think I can bring up myself there. Yep, good. So it's not a very big article, this one. Dead satellites still pose a threat to future space missions, as you can imagine. And the problem is only getting worse. So what can be done about it? It's no question that we have begun polluting the space around Earth, while governments around the world have participated in cataloguing and tracking the largest orbiting hazards. Astronomers have recently pointed out that the greatest threat to future missions comes from the smallest bits of debris, and it's the bits that currently go untracked. In a paper posted on August 27 to the ARXIV preprint server, 2 MIT astronomers found that future space missions need to have much better plans for disposing of satellites and rockets to create a safer space environment. Dodging the bullets. Otherwise, there are currently tens of thousands of known pieces of space junk orbiting Earth. While there are some larger pieces, like entire dead satellites, most of this junk consists of smaller pieces of debris, which include pieces of disintegrated rockets, bolts, and other parts that have fallen off larger missions, and even tools accidentally dropped by astronauts, or not so much dropped, but let go. Planners must take space junk into account for successful space missions to Earth orbit. Each of these pieces of junk is travelling at tens of thousands of miles per hour, and at those speeds, even the smallest piece can cause serious catastrophic harm to a mission. For example, the International Space Station makes an average one evasive manoeuvre every year to get clear of space junk. Currently, public and private space agencies rely on a network of databases provided by government monitoring groups, like the US Space Force. These groups use a combination of telescopes and radar to continuously monitor Earth orbit, providing real-time estimates of where the known pieces of space junk will be. But the space junk problem is only growing worse, especially with the rise of communication mega constellations consisting of tens of thousands of satellites. And what's worse is the MIT astronomers stated in their preprint, our current technology can only allow us to detect and track space junk down to a certain size limit, meaning that we do not yet have an accurate assessment of the risk that future missions may face. Currently, we can only track space junk larger than 4 inches or 10 centimeters, even though the vast majority of the debris in Earth orbit is smaller than that. Most of that small debris is considered non-lethal, lacking the kinetic energy to seriously damage a vital spacecraft component, but we have seen the damage that it can inflict. And for example, when NASA's replaced the solar panels of the Hubble Space Telescope in 1993 and 2002. And there's a picture of this damage. Let me just bring that up. There it is. And I'll just have to move myself out of the way there. So what you're seeing on the screen right now is one of the Hubble Space Telescope's solar arrays returned to Earth in March 2002 after more than 8 years in space, and it shows a 0.1 of an inch or 2.5 millimeter hole blasted into it by space debris, just like a bullet would do. Look at it, the damage it does. It's just amazing. And increasing an untracked problem, we have not yet been able to build a proper risk assessment for the lethal but non-trackable population of space junk, because we do not have the accurate accountings of the population, and simulating their hypothetical orbits to incredibly expensive. So instead, the MIT researchers used a probabilistic models, creating a range of scenarios that might play out over the coming decades of what the population of space junk may be and how often different types could lead to a catastrophic disaster. Their simulations include various scenarios of how many satellites are expected to launch in the next few decades, how much additional space junk each launch would create, and what the probabilities of benign and mission-ending collisions might be. They found that over the next 2 centuries, we can expect thousands of collisions, events triggered by objects too small to be tracked. Most of these collisions will be benign, but hundreds of them will still have the potential to lead to disaster. The researchers found that there is no way to completely eliminate the threat of this invisible space junk. We can only reduce the problem by employing rigorous standards for disposing of dead satellites at the ends of their missions. Historically, most satellites have remained in orbit after their useful life, with no propellant remaining. We have no way of changing their orbit, making them a high risk for future collisions that lead to an explosion in the population of smaller, untrackable debris. Including aggressive plans to deorbit satellites at the end of their lives and letting them safely burn up in the atmosphere can drastically reduce the risk of catastrophic collisions with debris in the future. At some altitudes, the risk of collision drops to a third of its predicted value without aggressive disposal, and overall number of collisions is cut in half. The only way to make the space around Earth safe for future missions is to continue our programs of monitoring and tracking. And for the smallest bits and space debris, we need regulations to ensure that mission designers include proper end-of-life plans for their satellites. Oh yes. Oh, well, there it is. You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night cast missions coming from the studios of VK3 CSJ. Ah dear, Cranbourne Road's a bit noisy tonight. I'm hearing all sorts of funny things going on. Sirens have just gone past and I can hear doors slamming, so it's probably an accident that's occurred at the intersection yet again. Next article. Alrighty then. ALMA reveals a star's surface in unprecedented detail. ALMA is the bunch of radio telescopes located at the Atacama, Chile observation area on top of a a mountain range, some, 9,000 metres up, I think, something like that. Anyway, new observations show the bubbling surface of red giant star D Doradus, a feat previously only achievable with the Sun. Doradus. And there's a little picture here of this, and I think there's a video associated here too, which I'll bring up in a moment. And I didn't bring that one across either. Okay, I've got it here though. It's image. Good grief. I'm trying to be so careful with this, and I still forget to bring images across. All right, to those watching video. Courtesy of astronomy.com, September 12. What you're seeing there on the screen right now, this series of images of star R Doradus, captured by ALMA, shows bubbles forming on the star's surface in incredible detail. The stars in the sky are so distant that they typically appear in pinpricks even to our most powerful telescope, or they appear as pinpricks even to our most powerful telescopes. Aside from our own Sun, only a few nearby bloated stars appear large enough to capture any features on their surface. However crude, new images released on September 11, however, capture one of the most detailed images ever of a star other than the Sun, and it's one that previews the fate of our own solar system. In research published in Nature, astronomers using the Atacama Large Millimeter Submillimeter Array, or ALMA, in Chile, capture of images of the star R Doradus, 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 that are so detailed it's possible to make out gas bubbles on its surface. Previously, this was only possible for the Sun. A few factors led to the ability of ALMA to discern such fine detail. The star is only 180 light years away, and as a red giant, it's both huge, 350 times the diameter of our Sun, and relatively cool. And each of the bubbles on the surface about 75 times the size of the Sun. Unbelievable. But don't let its huge size fool you. R Doradus mass is comparable to that of our Sun. When stars like the Sun exhaust their supply of hydrogen, the outer layers expand and they become a red giant star. This expansion vastly reduces the density of the star's outer atmosphere, meaning that despite the size of R Doradus bubbles, they are quite diffuse. Several, in fact, both our own Earth atmosphere is more dense than the outer layers of R Doradus. R Doradus is classified as a symptotic giant branch, or AGB star. A symptotic giant branch, AGB star, whose core is no longer undergoing fusion, but where helium and hydrogen are still fusing in shells around the inert carbon-oxygen core. We chose Doradus because it is one of the closest, possibly the closest, of the AGB stars. Study author Wouter Wilmings of the Chalmers University of Technology in Sweden says it is also the largest star after the Sun in angular size on the sky, so the researchers hoped it would yield the level of detail that they actually wanted. And I'll just bring up this actual video that they've put together. There it is. I've got that on a loop, so it'll just sort of loop. But as you watch this video, you can see the resolution of these bubbles actually coming into focus. And this is all done at radio wavelengths, I might add. The images are outstanding, and Vlemings says they closely match predictions of what such a red giant star should look like. That means our predictions for the path of our sun might take on its death spiral in a few billion years are likely correct, and R. Doradus offers a bit of a preview. So how long does R. Doradus have left? Vlemings says it's hard to say, but the typical length of this stellar phase is of the order of 1,000,000 years, so it still has a few 100,000 years to go. The team is now planning follow-up observations on the star, hoping to gain more insight on how gas in the atmosphere behaves. They also want to study similar stars for flares and hotspots to better understand how convection, the transfer of heat outward, might work on the surface. Most of these future observations, they'll still need ALMA. The array of radio telescopes doesn't form traditional images as one might see peering through a telescope. Instead, the 66 receivers work in tandem to gradually build one huge observation of an object at wavelengths longer than those of visible light. This means that ALMA can be tuned to gather details on objects too bright to dissect invisible or infrared light. These stars are actually too bright for JWST, meaning that they would be very hard to study without saturating the telescope. Vlemings said, though he adds that the space telescope could be used to inspect the region around the star for gas outflows. So while the James Webb Space Telescope is typically used to peer deep into the universe's past, in this case researchers are using ALMA for a glimpse of its future. Whew. Alrighty then. It's an interesting image, and like I say, that is being created by RF energy being detected by a bunch of small telescopes. All right, where's my camera? Okay, next image, as in next article. And where are we? What time is it? 10:38 already. Wow, how quick that's gone. All right, I guess if anybody watched the 6 o'clock news tonight, you might have seen the video footage of the Polaris Dawn crew, which completes its historic private spacewalk. SpaceX commander Gerard Isaacman and mission specialist Sarah Gillis each spent a few minutes outside the Dragon capsule performing tests on their spacesuits. I find that hard to believe. I mean, you actually go right out into space, into the real environment, to test a spacesuit. What if it failed? Anyway, all right. Let me just quickly go through this one. The 4-person crew of SpaceX's Polaris Dawn mission made history on Thursday morning by completing the first spacewalk with private astronauts. Commander Gerard Isaacman, the billionaire CEO of Shift4 Payments, who purchased the 5-day orbital flight from SpaceX. The mission specialist Sarah Gillis, one of the crew's 2 SpaceX engineers, who are the company's first employees to fly to space, exited SpaceX Dragon's capsule one at a time, each spending about 12 minutes outside. The astronauts were travelling at 17,500 miles an hour at an altitude of more than 450 miles above the Earth, higher than the International Space Station. You'd want to hope so. Because Dragon does not have an airlock, All 4 crew members were exposed to the vacuum of space, and the mission profile added risk compared to a typical spacewalk where the astronauts enter and exit through a vacuumed sealed chamber. And I've got a little bit of video of this happening, so let me just bring that up. There it is. Drop that across. This is just on a bit of a loop at the moment, so you can see this bloke floating around through the airlock as such. And there's another bit of video here which shows the Earth in the background. There it is. So today's EVA was the first time 4 humans were exposed to the vacuum of space while completing the first ever commercial astronaut spacewalk from a commercially produced spacecraft in commercially produced extra vehicle activity (EVA) suits. SpaceX provided live stream coverage of the full approximately 2-hour process, which can be rewatched online. The Falcon 9 rocket carrying Dragon and the Polaris Dawn crew lifted off from Launch Complex 39A at NASA's Kennedy Space Center in Florida early Tuesday morning. Almost immediately, the astronauts began preparing for the spacewalk. The first step was a pre-breathe, to remove nitrogen bubbles that can form within body tissues. Oh, scary. Causing decompression sickness. During the approximately 2-day process, the cabin's pressure was lowered and oxygen levels were raised gradually to help the crew acclimatize. After that, the astronauts donned their EVA spacesuits, which are designed to be worn both inside and outside the spacecraft, developed by SpaceX with help from Isaacman Polaris team. The suits have endured hundreds of hours of testing, well, that's good, and feature greater mobility, durability, and even high-tech heads-up display, HUD. Building a base on the Moon and a city on Mars will require thousands of spacesuits, and SpaceX said in a post on X, the development of this suit and the EVA performed on this mission will be important steps toward a scalable design for spacesuits in future long-duration missions. After completing the suit leak checks and venting Dragon down to vacuum, the sentence construction, really. After completing suit leak checks and venting Dragons down to vacuum, Isaacman opened the hatch and was first to egress. Remaining attached to the spacecraft, he used a specially designed structure called Spacewalker to move around and perform tests on the suit's thermal and mobility systems. Skywalker is equipped with several cameras that were used to capture the moment in time. SpaceX, back at home, we will have a lot to work to do, Isaacman said as he looked down on the planet below. But from here, Earth sure looks like a perfect world. After Isaacman returned, it was Gillis's turn. The SpaceX engineer stepped out and performed the same series of tests, while mission pilot Scott Kidd Potit and mission specialist and medical officer Anne Menon monitored their support systems. Finally, the hatch was closed, Dragon was repressurized, and the astronauts removed their suits. Dragon uses pure nitrogen during repress, which mixes the pure oxygen being released into the cabin via the open-loop system that keeps the EVA suits pressurized, SpaceX said. This process is unique to Dragon, which acts as its own airlock. From venting to repressurization, the entire process took about 1 hour and 45 minutes. SpaceX CEO Elon Musk was quick to praise the crew for its historic achievement, and was NASA's administrator Bill Nielsen. Congratulations NASA's Polaris program and SpaceX on the first commercial spacewalk in history, Nielsen posted on X. Today's success represents a giant leap forward for commercial space industry and NASA's long-term goal to build a vibrant US space economy. I'll leave that there, really. So, yes, good luck to those folks. I'm glad to see that things worked out well for them. It could have been, well, I wouldn't say it could have been disastrous, because I'm sure they're pretty good with their engineering. You want to hope. But that's a great shot, though, isn't it? Floating just above Earth like that. It's just amazing stuff. Oh dear. All right. You're tuned to ASV Radio, VK3 EKH, the official station of the Astronomical Society of Victoria. At 10:46, next article. China plans to build a moon base at the lunar South Pole by 2035. Courtesy of space.com, published September 10, 2024. The ambitious project consists of two phases, the first of which aims to complete a basic lunar outpost roughly a decade from now. China has revealed that its moon base plans will be rolled out into two distinct phases, eventually creating a series of nodes on the lunar surface and in orbit. The initial roadmap for the International Lunar Research Station, ILRS, jointly led by China and Russia, was unveiled in June 2021. The pair stated plans to build a basic robotic moon base through 5 super heavy lifting rockets launches from 2030 to 2035. China has now taken the lead in the project and revealed more advanced two-phase plans for the ILRS at the second International Deep Space Exploration Conference in Chinese province on September 5. The first phase will be completed around 2035 near the lunar South Pole, and an extended model will be built by about 2050, according to the engineering chief designer of the Chinese Deep Space Exploration Project, speaking to a media at the event. And there's just a little bit of a artist's impression of this base here. There it is, coming up. So China has revealed that its moon-based plans will be rolled out in two distinct phases. Yes, I've already read that, Clint. The extended model will be a comprehensive lunar station network that utilises the lunar orbit station as its central hub and the South Pole station as its primary base, and it will include exploration nodes on the lunar equator and at the far side of the moon. Further details include ILRS being powered by solar, radioisotope and nuclear generators. Further infrastructure will be moon, earth and high-speed lunar surface communication networks, lunar vehicles like a hopper and a unmanned long-range vehicle, and pressurized, unpressurized crewed rovers. Notably, the extended ILRS model would help lay the foundation for future crewed landings on Mars. China has been attracting partners for the ILRS during the conference. I'm just trying to read ahead here. During the conference, 13th country to sign up to the project. Senegal, that must be a country. I thought it was somebody's name. Senegal, Senegal, Senegal. It's a country. Don't know where that is. Senegal became the 13th country to sign up to the project. Meanwhile, NASA is leading Artemis, a parallel but separate program to return people to the moon. Both China and NASA aim to put astronauts on the moon before the end of the decade. All right, that was courtesy of space.com. I think that's where it was from. Did I just say that? Yep. And now we're coming up to the end, actually. This last article before I run with Timothy. How long is this article? Let me just check that. Oh no, it's not very long. Okay. Lonely Space Probe measures the true darkness of the universe. September 6th, 2024, courtesy of ScienceAlert.com. And there's a little image here too. It's a bit of an artist's impression again. But I was going to read this out last week, so this is a leftover from last week. A long time ago, in a far a long way from home, a lonely space probe hurtles ever deeper into darkness of space. At a distance of just shy of 60 astronomical units from the Sun, New Horizons is the most advanced human-built instrument to ever make it so far. This means that we now have a spacecraft that can take unprecedented images of the universe unpolluted by the light of the Sun glancing off the interplanetary dust scattered throughout the solar system. Now scientists have measured the true darkness of the universe by taking the most precise measurements yet of the faint background of visible light that permeates it. This is the cosmic optical background, and New Horizons' new measurements show that, contrary to previous measurements, there's absolutely nothing strange about it. We now have a good idea of just how dark space really is, explains astronomer Mark Postman of the Space Telescope Science Institute. The results show that the great majority of visible light we receive from the universe was generated in galaxies. Importantly, we also found that there is no evidence for significant levels of light produced by sources not presently known to astronomers. Observing the universe from within the solar system is a little bit like trying to see a room from inside a dirty fishbowl. There are elements in the surrounding space we need to correct for, mainly the light of the Sun and the diffuse dust and gas that hangs out between the planets. Most observations on the interstellar and galactic medium, we have ways of working around such obstacles. The spread out glow of all visible matter in the universe is simply too faint to extract from the interference within the solar system. People have tried over and over to measure it directly, but in our part of the solar system there's just too much sunlight and reflected interplanetary dust that scatters the light around into a hazy fog that obscures the faint light from distant universe, says astronomer Todd Lohr of the National Science Foundation. All attempts to measure the strength of the COB from the inner solar system suffer from large uncertainties. NASA's New Horizons probe was sent to study the outer solar system, including Pluto, as part of the flyby in 2015, and various objects like the Kuiper Belt. Its mission has offered the best opportunity yet to capture the light beyond the fishbowl. At 60 astronomical units from the Sun, there's still a lot of dust, but the Sun's light is faint enough for the cosmic optical background can be measured. The first attempt at measuring the cosmic optical background with New Horizons instruments in 2021, however, returned results that were quite weird. Yes, the background was there, but it was much brighter than expected, which scientists struggled to explain. The new attempt was made in the second half of 2023. This time the scientists used far-infrared data on Milky Way dust clouds collected by the European Space Agency Planck mission to calibrate the New Horizons data. This allowed the astronomers to correct for the amount of dust in the Milky Way galaxy. The results showed that in the previous analysis, the team had underestimated the amount of dust in the Milky Way and subsequently overestimated the amount of excess light coming from the rest of the universe. The new observations and analysis reveal that actually the universe is emitting as much light as we expected it to from sources we expect. The simplest interpretation is that the cosmic optical background is completely due to galaxies. Looking outside the galaxies, we find darkness there and nothing more. Considering the darkness could be hiding in any number of cosmic horrors that perhaps not much comfort, but at least we don't need to come up with new physics for now anyway, he says. Right. So that's courtesy of spacealert.com. Lonely space probe that measures the true darkness of the universe. Sorry, I just thought I'd do that Star Warsy thing. Why did I do that? Anyway, where is my camera? There is my camera. And now let's bring up Tamitha. Tamitha, where's her favourite picture? There it is. All right, stand by for latest Tamitha space weather report, which is, oh my God, it goes for 13 minutes. Oh, I'm going to go over time. Look at that. I was going to try and keep it under. Oh, I'm so sorry. Well, wouldn't it bother you? All right, stand by, and we shall cut across to Tamitha right now for the latest report. Oh dear, that high blood pressure tablet must be kicking in. Stand by.
We have 2 solar storms on their way to Earth with a fast wind chaser. And some big regions are rotating into Earth view, and they've already shown that they are big solar storm and big flare producers. Those stories and more in the news this week. Space weather this week picks up in a big way. As we take a look at our Earth-facing disk, look at all the active regions in Earth view. We are saying goodbye to region 3806 and 3807 as they rotate to the sun's far side, but we'll get back to those in a minute because they're making a ruckus on the sun's far side. In actuality, we've been paying close attention to this kind of cluster of active regions here with some filaments that look like they were going to erupt, but thus far, most of the eruptions have been southward. But take a look at region 3821 as it begins to emerge here. There's a filament that lets go. Whoosh! Right there. Did you see that? That is an Earth-directed solar storm. In fact, as we take a look at coronagraphs, you can see much of the material here launching to the northeast of Earth, but there's a little bit of something right here. So this is an Earthward-directed solar storm, and we're expecting it to hit us any time now. On top of all of that, you can see we've got a little bit of activity from these regions here. Region 3814 picks up in a little bit, but let's go back to region 3806. You can see it on the sun's far side begin to kind of get really active right there. That was a big solar eruption, and then you can see a big whoosh that pop right there. Both of these far-sighted eruptions have created radiation storms that we're dealing with right now. We'll talk more about that in a minute, but it shows you that we've got some activity that's about to rotate into Earth view. In fact, the one on the that's just behind the east limb, it fired off back on the 3rd. It fired off a big X-class flare. This is an X2.4 flare, and you can see from the STIX instrument where it was located on the sun at that time. It was rotating almost center disk on the sun's far side. Then back on the 5th, we had an almost M8 and another X2.4 class flare from the same region. And again, when we take a look at where it was located, well, now it's rotated past center disk on its way to coming back around in Earth view. And then, believe it or not, on the 7th, it fires off an M-class flare and another radiation storm. So we've actually got some big flare players on the sun's far side. This one's about to rotate into Earth view. You can see some activity here. This is from region 3806 that just rotated to the sun's far side. So this far side is definitely lighting up, and we're expecting to see more. You can see these 2 regions right here that are going to rotate into Earth view. Meanwhile, we're not done yet with the Earth-directed solar storms. We've got region 3814 lights up a big solar eruption right here. You can hardly see that, but when we take a look at the coronagraphs, this is the stereo coronagraph. Again, much of the material is going kind of north of Earth, but you can see this really faint halo right here. So once again, we have yet another Earth-directed solar storm. This one's going to hit us sometime on the 12th, and so these are going to be back-to-back, and depending upon how closely they hit as a 1-2 punch, we could get some big storming even down to mid-latitudes. Now, switching to our full sun map, we take a look at SDO AIA imagery to see what's on the sun's front side, of course, but we also take a look at EUI imagery from Solar Orbiter to get an idea of what active regions might be lurking on the sun's far side. Now, as we set this map in motion, you can get oriented by looking at region 3806. That one is going to be rotating to the sun's west limb, but then also region 3821 and region 3814 as it rotates into view here. These were the two solar storm launchers that have those two Earth-directed solar storms that are coming toward us now. But also take a look at the sun's far side. We have two big active regions on the what's about to become the east limb here. These are the regions that have been firing off those big X-class flares, and last time they were in Earth view, they were big flare players. That looks like we've had a lot of growth in these regions, so as they begin to rotate into Earth view again, expect that big solar flares are going to be back on the menu at R3 level radio blackouts. And for you aurora photographers, even after we get these two solar storms hitting us, kind of dying down, we do have some big flare players and big solar storm players that are going to be rotating here into the Earth strike zone over this next week. So expect that we could have some big Earth-directed solar storms once again after all of this dies down. Now, as we switch to our radiation storm monitor, over the past week, we've actually had a bit of a radiation storm twice. These storms are from the big flare players on the sun's far side that are wreaking havoc there. Now, back on the 2nd, we actually peaked at almost an S1 level, but things kind of died back down. Likely the radiation storm was much stronger on the sun's far side. But then we got hit again on the 9th by a second radiation storm. This one was it was likely from region 3806 that's just disappeared around the sun's far side. But this one actually did peak up over the S1 level. It is dying down now. But as those Earth-directed solar storms end up hitting Earth, there's a chance that this radiation storm level could peak back up close to the S1 level before it finally begins to die down completely. So amateur radio operators and you GPS users, if you're at high latitudes, expect communication and navigation issues as long as these levels are elevated, which will be easily over the next few days. And then stay on alert when those new regions rotate into Earth view, because we could get more of these. Now, returning to those two Earth-directed solar storms, we take a look at our solar storm prediction model, ENLIL. Now, this is NOAA's version of the model. The top panel's density, the bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. And as we set this solar storm model in motion, you can see the solar storm being launched. This is the first of the two. This solar storm is being launched mainly to the west of Earth and slightly northward of Earth, but nonetheless, it manages to give Earth a direct hit, and this is expected to be late on the 10th according to the NOAA model, but it might actually be a little bit later. In fact, as we switch to the NASA version of the model for this model run, again, we're looking down at the sun from the North Pole with Earth being off to the right. As we set this model in motion, you can see the solar storm coming out here. It's going to hit Earth a little bit more of a direct hit than I think NOAA's version has it, but it may be as far as early on the 11th by the time the solar storm hits. So we kind of have a bracketed window. Now, if this solar storm is a bit on the slow side, then that's going to be it. That's going to mean something, because when we take a look at the next solar storm that's being launched, again, we're just looking at the NASA version because they have their model run out right now. NOAA, we're still waiting for their model run. You can see this second solar storm being a bit more of a direct hit. This storm should hit us late on the 12th. So it could be that these two solar storms kind of go back to back. And I don't know if they're going to influence each other, but what's going to happen is that Earth is going to be what we call preconditioned. So therefore, it's going to be kind of loaded. So when the second storm hits Earth, it's already kind of on a hair trigger. And so we could get stronger storming when this storm hits on the 12th. So aurora photographers, even if you're at mid-latitudes, you could definitely get a show. Aurora could definitely come down to, deep into mid-latitudes, and it could be an extended storm from basically late on the 10th clear to about the 13th or 14th before things calm down. So definitely keep your batteries charged. Switching to our moon, we are now passing through the second quarter phase on our way to a full moon, with a full moon being on the 18th. So you night sky watchers, if you want to catch those dim objects in the sky, like, I don't know, maybe some aurora, you're going to have this bright companion to deal with. So you're going to need to check your local rise and set times. Switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating those 2 solar storm hits coming back to back. So at high latitudes, NOAA is expecting major storm conditions with up to about a 65% chance of a severe storm. This is going to be on the 12th because we're going to be calming down from one solar storm and then getting hit by the second. So likely the 12th will be when we have the best chance for aurora, although we should be at high latitudes storming pretty much through the 13th. Then after that, right around the 14th, we'll be calming down a bit. We'll probably have a bit of a fast wind chaser, so we could still see aurora clear through the 14th before things finally calm down on the 15th, and we'll be looking back at the sun for even more chances for solar storms. Now, at mid-latitudes, well, conditions aren't quite as strong, but we are expecting up to about a major storm on the 12th. Again, that's because we're going to have back-to-back solar storms, and the second one should be hitting right about here. We could have about a 20% chance of a severe storm, but that's being possibly a bit optimistic. We shall see. Meanwhile, things should then begin calming down on the 13th. We will get a bit of fast solar wind chaser, which might cause aurora to be sporadically lingering at mid-latitudes. So aurora photographers, you do, even down at mid-latitudes, get a decent chance to chase. So make sure you are ready. Now, switching to our solar flare and dayside radio blackout outlook over the coming week, we do have a lot of active regions in Earth view, and the ones to watch this week are region 3814 and 3822, and of course the east limb, because we have those new flare players that are going to be coming on board. Our solar flux is sitting well into the 200s, and this means good radio propagation on Earth's dayside, but we do have some moderate noise levels, and this is likely going to continue over this next coming week, with possibly it getting a little bit worse. NOAA is giving us about a 55% chance of M-class flares. This is at the R1 to R2 level radio blackout level over the next couple days, and a 15% chance of radio blackouts at the R3 level due to X-class flares. And likely that will boost just a little bit as we move into the latter part of this week because of those new regions rotating into Earth view. So amateur radio operators and emergency responders, expect that the big radio blackouts are back on the menu, and the bands will continue to worsen over this next week, so you're just going to have to grin and bear it. Switching to our radiation storm and polar aviation outlook over the coming week, we are sitting at the D2 minor range, and this is for you aviators at flight level 360. We're also sitting at it just below the S1 storm level, just an elevated flux level for everybody else, and this is going to continue to be an issue over the next couple days. NOAA is giving us about a 50% chance of reaching S1 to S2 levels over the 24 hours, and on the 12th, I'm bumping this up to about a 90% chance because we have those Earth-directed solar storms that are moving through. But after that, things should quiet back down, and by about the 14th or the 15th, we should be back at the D1 normal range, assuming we don't have any more radiation storms launched from those new regions that are rotating into Earth view. So you frequent flyers, and this does include air crew and high-risk passengers, please check those ICAO advisories often and make sure you take these conditions and consider them in your flight plans. So the space weather this week has gotten very active. We have 2 solar storms on their way to Earth, along with a fast wind chaser. This could give you aurora photographers some extended aurora, even down into mid-latitudes until about the 13th before things really calm down. So be sure to keep your batteries charged and keep your eyes on the skies. And now you amateur radio operators and emergency responders, well, things have been reasonably quiet for you, but things are beginning to get worse. Not only do we have those solar storms that are going to wreak havoc on Earth's night side, but now we have some new regions that are going to be rotating into Earth view over the next couple days that are big flare players again. So expect R3 level radio blackouts to be back on the menu, and possibly even more solar storms, as well as big radiation storms that then cause problems for you both in the north and the south poles in those high latitude regions. So just kind of grin and bear it and get through it over the next week. Things will calm down. And now you GPS users, well, things aren't looking all that great for you either right now. We have 2 Earth-directed solar storms that are going to give you GPS reception problems on Earth's night side, especially anywhere near Aurora. On Earth's day side, we have those new regions that are going to be rotating into Earth view that are going to be giving big radio blackouts, so that could give you some GPS reception problems near dawn and near near dusk. And if you happen to be at high latitudes, well, we have those ongoing radiation storms that are giving us issues at the north and south polar regions. So just be careful and be vigilant all over, and make sure that when those solar storms hit, that you calibrate your magnetometers often. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Feedbacks. Thank you, Tamitha, for a fairly extensive report there. Excellent stuff indeed. Looks like the good old sun is up to its usual status at the moment. Let me just quickly go into our own little space weather report here, courtesy of spaceweather.com. Currently, the solar wind is at 470.5 kilometres a second. It must be a typhoon. And density is 1 proton per cubic centimetre. The current disk of the sun is looking a bit like this right now. There's a few sunspots there to speak of. And the sunspot number is currently 160. The radio sun, measured at a wavelength of 10.7 centimetres, is 201 solar flux units. The auroral oval over Antarctica at the moment looks a bit like this. So there is potential for auroral imagery to be taken from Tasmania, most likely the mainland. But that's a kind of a 50-50 thing happening there. So certainly some auroral activity is possible. The coronal hole, there's a couple of coronal holes on the disk of the sun too, which I think I've got a picture of. Or at least there's one here. Oops. Oh, that'll do. I pressed the wrong button. But anyway, there we are. So there is a coronal hole. The image I'm seeing here on Spaceweather might have been just recently updated. But there are two coronal holes currently that's facing Earth, and one's at the top and one's at the bottom. But for some reason, the image that I saved is a slightly different image. And so, as Space Weather Report reports, a new source of solar flares, a large and complex sunspot, as mentioned by Tamitha, just emerged over the sun's southeastern limb. Yesterday, it produced an X 1.3 class solar flare, even before the underlying sunspot was fully revealed. Any flares this weekend will be definitely Earth directed, so there's definitely going to be some activity for sure. And this interesting image also coming off spaceweather.com. A CME sparks widespread red auroras. A CME hit Earth's magnetic field on September 12. It was debris from a dark plasma explosion on the sun's 4 days earlier. The impact sparked a G3 class geomagnetic storm with red auroras deep inside the United States. Ross Stone sends this picture from the Owens Valley Radio Observatory near Big Pine, California. He says, I looked outside at 3:30 a.m. and saw red in the northern sky, says Stone. I hurriedly grabbed my camera and headed to the coolest place I could think of to photograph the aurora. It was a glorious sight under these beautiful radio telescopes. The storm has subsided, but it could flare up again this weekend when one of or two more CMEs are expected to arrive. But the glow was reflected off the dish of the radio telescope, which is quite an amazing picture there. And of course, again, as Tamitha said, and as Space Weather Report com is saying, there are definitely something abreast. 2 more CMEs are coming. Active sunspot AR3814 is crackling with M-class solar flares. The the explosions have hurled at least 2 or more CMEs toward Earth. So everybody is saying it. So there it is. Okay, final comment. As of September 13, 2024, there are 2,349 potentially hazardous asteroids, and I suspect that none of those asteroids are on a collision course with Earth, though. So on that note, you've been listening to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. All information about the radio station here can be found on qrz.com. Just type in VK3EKH, qrz.com. Information about how to connect to Discord is now available there. So like I say, you have to register with Discord, get that all sorted out first, and then the link that I provide on the qrz.com page you can click on, and that'll automatically take you straight to the ASV chat room and consequently onto the HD stream, which there's a few people seeing or watching tonight. So there it is. Let me just have a quick look at that too. So I think one of the fellows has dropped off tonight. Brett seems to have gone to bed early. But g'day to Bruce and of course Steve and Mike as well, still hanging in there. Thanks for the emails too from the various folks. G'day Andrew, VK3KIS has chimed in, and Mr. HK's gone off to have a shower. So all right, that's fine. I think that's about it. So now I shall go across to the main frequency and see if there's any stations wishing to to check in for tonight. I apologise going to 11:16. I really didn't think I'd go that far, but there it is. Okay, so I've got that ready, and I've got that ready, and I think we should be able to do this successfully. Let me just get that unmuted, and I think that's the audio level from the receiver, so that should be all right. This is VK3EKH listening on 3541 kilohertz.
VK3GL, VK3STX.
Right. Any other stations? See, that's what happens when I go over time. G'day, Graham from Bunyip.